Hello folks, we are taking the last part of the miscellaneous exercise chapter 3 part 5 and here we are trying to find out the ratios that they have asked us to find out, sin x by 2, cos x by 2 and tan x by 2. We are starting with the ninth problem which says that cos x is equal to minus 1 by 3. It's given to us that cos x equal to minus 1 by 3 and x is in the second quadrant. So we have to analyze. If x is in the second quadrant, what will happen to x by 2? If x is in the third quadrant they have told. So because it is in the third quadrant, it is something of the type maybe 210 or maybe it is of the type maybe 240, something that is less than 270. If that is the case, you take its exact half, we will get to know that all the x by 2's they will lie in the second quadrant. So therefore, our x by 2 angle is going to be lying in the second quadrant. This has to be there in our mind when we do our calculations. It's been given to us that cos x is minus 1 by 3. Directly you can proceed from here to find the remaining trigonometric ratios, or you can convert this into tan and convert it into sec and then find out. That's your own wish. So let's start right away. Here cos x can be told as 1 minus tan squared x by 2 by 1 plus tan squared x by 2. We know it's a formula, so let's use it. 3 can go here, this can come here. 3 times 1 minus tan squared x by 2 minus 1 times 1 plus tan squared x by 2. So what will come here? 3 minus 3 tan squared x by 2, and here it's minus 1 minus tan squared x by 2. Let's have the tans on one side. So you could have this coming here and could have this coming here. So you have 3 plus 1 which is 4, and this will go there. It will become minus tan squared x by 2 plus 3 tan squared x by 2. What comes up 4 here? Here it is 2 tan squared x by 2. So when we have it solved, tan squared x by 2 comes to 2. 4 divided by 2 it's 2, and therefore tan x by 2, now this we have analyzed that it is in the second quadrant, and in the second quadrant tan is negative, so therefore tan x by 2 is minus root 2. So that's how you have got the tan x by 2 value. They ask us to further find sin x by 2 and cos x by 2. So having got tan squared x by 2, maybe you can get sec squared x by 2. Sec squared x by 2 is 1 plus tan squared x by 2. That means it is 1 plus 2 which is 3. Like that, sec x by 2 will come to minus root 3, and therefore cos x by 2 will come to minus 1 by root 3. Having got this, you can get the sin squared value. So cos squared x by 2 is basically going to be minus 1 by 3, and therefore sin squared x by 2 is 1 minus cos squared x by 2. It's 1 minus, so one second, because it's square it will be positive, so it will be 1 minus 1 by 3. So that way it will come to 2 by 3 when we solve it, into 3 into 3. So that way 3 minus 1 by 3, 2 by 3. Therefore sin x by 2, because it is in the third quadrant, it will, sin x by 2 is in the second quadrant, it will come to 2 by root 2 by 3 when we take the root. So it will be positive because it is in the second quadrant. That is about these values. We have got tan x by 2, we have got cos x by 2, we have got sin x by 2. Now having got that, we have one more last question left. Let's get back to that question. Yeah, so our last question, and last question is a little lengthy also. It says that sin x is 1 by 4, and this is in quadrant 2. It's in the second quadrant. So we know that if x is in the second quadrant, automatically x by 2 is going to be in the first quadrant. So the sin x, which is 1 by 4, we are going to apply our tan formula, and by tan formula we know it is 2 tan x by 2 by 1 plus tan squared x by 2 is equal to 1 by 4. Solve it, have it on the sides. So you have 8 tan x by 2, 1 into this thing. So it is 1 plus tan squared x by 2. Everything on one side. Tan squared x by 2, this can go there. Minus 8 tan x by 2 plus 1 equal to 0. Now this expression, it's a quadratic in tan x by 2, and if you feel that you're not able to maybe factorize it, let's directly go in for the discriminant formula or the quadratic formula and get the answer. We all know the quadratic formula. Quadratic formula says that any variable that you need to find can be found out by minus b plus or minus root of b squared minus 4ac by 2a. So that way you will have the tan x by 2 value by the discriminant formula or the quadratic formula as minus b, which is plus 8, plus or minus root of b squared, 8 squared, 64, minus 4ac, that's 4, by 2a, which is 2. So 8 plus or minus 64 minus 4, 60. 60 is 15 into 4. So when we solve, you can have this written as 2 into 4, and this will come out, it will become 2. So therefore the 2 from everywhere, you will have 2 times 4 plus or minus root 15 by 2. It will get cut, get the answer as 4 plus or minus root 15. Now this is the value of tan x by 2. From these values of tan x by 2, you have to find out the sin x by 2 and cos x by 2 value. So both the values, if we find out the value of root 15, both the values are applicable, because both values will come as positive, and therefore both the values are applicable, and therefore we have to take both the values and find out their corresponding sin x by 2, cos x by 2 values. So let's see here. For tan x by 2 to be equal to 4 plus root 15, what will be its cos x by 2 value and sin x by 2 value? Let's find out. Tan x by 2 if you are given, and you have to find out the cos x by 2 value. We know that sec squared x by 2 is going to be 1 plus tan squared x by 2. Yeah, and 1 plus tan squared, in this case 4 plus root 15 the whole squared. What will it come to? 4 squared 16, root 15 squared 15, 8 root 15. How much does this come to? 32 plus 8 root 15, that is sec squared. So what is sec x by 2? It is the root of this, 32 plus 8 root 15. So what is cos x by 2? It's in the first quadrant, so it's positive. That's all. You can solve it further, but it's okay if you leave it also. So once you get the cos, you can get the sin also. So because cos is this, sin squared x by 2 is 1 minus cos squared x by 2. So that is 1 minus square of this. So 1 by 32 plus 8 root 15. Now we'll equalize this into this 32 and in the numerator also. So it is 32 plus 8 root 15 minus 1 by 32 plus 8 root 15. So you have 31 plus 8 root 15 by 32 plus 8 root 15. So you have sin x by 2 becoming positive, of course, 31 plus 8 root 15 by 32 plus 8 root 15. That is our sin x by 2 and cos x by 2 value for this value of tan x by 2. Now we have to do the same thing for the other value of tan x by 2. So let's take the tan x by 2 to be 4 minus root 15. Now let's see how to go about it. Same way, sec squared is going to be 1 plus tan squared. So that way it is going to be 1 plus 4 minus root 15 the whole square. It's going to be 1 plus 16 plus 15 minus 8 root 15. So 32 minus 8 root 15. Sec is root of this. So what is cos? 1 upon. So 1 upon root of 32 minus 8 root 15. So sin squared is going to be 1 minus cos squared. Then equalize into this, into this. So 32 minus 8 root 15 minus 1 by 32 minus 8 root 15. So you have 32 minus 1, 31 minus 8 root 15 and 32 minus 8 root 15. So you have the sin x by 2. It's a positive value. So we have finally found out the cos x by 2. You have the tan here, you have its sine here. Similarly, you have the tan here, you have the cos here, and you have the sine here. So though it's a bit elaborate, when we do it systematically, we are able to get the answer. That is about the part 5 of our miscellaneous exercise, chapter 3. In the next video, we take the new chapter. Thank you.